Good morning, children. Most of you were able to complete these 3 ray diagrams, which I taught on the other day. Good. We are left out with 2 cases, case 4 and case 5. Okay, we're going to do that right now. So we'll start with case 4. Object between C and F. C is center of curvature, F is principal focus. Okay, object between C and F. Okay, so as usual, first you draw your mirror like this. Okay, before that, listen to me. You're going to draw this along with me. Okay, so please pause it, go bring your scale pencil, and you're going to draw it along with me. Okay, so case 4, object between C and F. And then, okay, now as usual, you're going to draw the principal axis in the middle line. So this is P, and then 2 centimeter will take 12. Okay, so this is F and this is C. So object between C and F. So this is my object A, B. Okay, so between C and F means anywhere you can take. You can take here, 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 anywhere in this space you can take anywhere. Okay, so from this point, as usual, we have to draw 2 rays. First ray parallel to principal axis. After reflection passes through principal focus. Second ray passing through principal focus. And after reflection comes parallel. Okay, so both the reflected rays meet here. So there you draw a line, mark it as A dash, B dash. Okay, so AB, immediately you label it. AB is the object and A dash, B dash is the image. Okay, I hope you got it. All of you got an inverted image, and remember it should be longer than the object. Okay, see, this is 1.4 centimeter or something. So the image should be bigger than the object. Now we are going to write the characteristics or nature of image. First one, size is bigger, we write enlarged. Second, inverted, because A is at the bottom and B is at the top. Here A was at the top, here A is at the bottom. 3, real. And fourth characteristic, where is it formed? It is formed beyond C. Okay, it is formed beyond C. So beyond C. Yeah, little bit here. So when you draw properly, you might get it somewhere this side. So these are the 4 characteristics or nature of image. Hope you got it, children. This is the case 4. Now we go to case 5. Object at F. Case 5 is object at F. Okay, so the mirror then principal axis 2 centimeter, P, F and C. Object at F means at F you draw a 1 centimeter long line exactly at F. Okay, so this is your object A, B. First ray parallel to principal axis, after reflection goes through principal focus. Through this point itself it will go. Now second ray we usually take the ray passing through principal focus. Now you can't do that because already your ray is at F. So you cannot use that rule. So you have to use the third rule. Okay, we didn't use it much, but here we are going to use this one, third rule. What does the rule say? Any ray passing through C will come back along the same path. So we are going to use the same rule. So what you have to do is you have to keep your scale between this point and this point and draw a line, straight line, and draw a straight line. Not beyond this. Okay, so both the direction arrow marks should be there. So this is your C. So these are the two reflected rays. One is this, the other one this. How do they appear? Do they look parallel? Yes, they are parallel and they are not going to meet anywhere. Okay, so what we say, image is formed at infinity. Somewhere very far away they may meet. So we say image formed at infinity. So in this you can't show the image. So you just write AB object. And then nature of image. Highly enlarged. Okay, we can't see that, but it will be highly enlarged. Okay, then inverted, then real image, then where is it formed? At infinity. Okay, so this is how case 4 and case 5 has to be done. I hope you have drawn along with me and you're clear with the diagrams how to draw. Okay, now after the diagram there is a table that is given, image formed by a concave mirror. So there is a table which talks about position of object, position of image, size of the image and nature of image. Okay, now if you would have noted all the diagrams, object is shifting from a far away distance. We started at infinity. Infinity means very far away. Then it was beyond C, then it was at C. Can you see the object being moved towards the mirror? So in this it was at C, then it was between C and F, then it was at F. So object has been moved from infinity towards the mirror. So position of image, if you see, in the first case it was at F, second case it was between F and C, third case at C, fourth case beyond C, and fifth case infinity. So image is going away from the mirror. Okay, so there is a sequence that is followed. Okay, then size of the image also, if you see, in the first case it is highly diminished. Okay, in the diagram that I gave, you will get only a point size object, just a point sized object. Yeah, then diminished, then same size. Okay, you can see the size increasing slowly. Okay, then diminished, then same size, then enlarged, then this one highly enlarged. Okay, then all are real and inverted. So this is how the if you study it together, you need to do a comparative study like this. Okay, so that's all about the ray diagrams, and Now we go to the last topic, not last, uses of spherical mirrors. Okay, we have separately uses of concave mirror and uses of convex mirror. First use, concave mirrors are used as makeup mirrors at beauty parlors and shaving mirrors. If you remember that video which I had put last week, not the video I took, some other video I had put, you saw in that that man showing a shaving mirror. Okay, and that is concave mirrors are used for that. Second one, they're used as reflectors in torches. Okay, so it is seen torch lights having concave reflectors like this. Okay, bulb will be here and then there will be a highly polished, this will be a concave reflector. It will reflect the rays and send it. Okay, so reflectors in torches, headlights of vehicles, car and bikes, headlights, they all have concave mirror. Third one, they're used by doctors to focus light on a specified organ such as tooth, ear, nose, throat. So there's a doctor, you would have seen a specialist called ENT, ear, nose, throat. He will always have one torch kind of a thing in his forehead. Okay, he has a band around and there's a small torch. Now inside the ear, if he has to see, so it's going to be very dark and very minute things, so he uses that torch. That is a concave mirror basically, and the rays will be focused and he can see it clearly. Fourth one, they are used in solar cookers and solar furnaces. Okay, uses of convex mirror, it is enough if you write till this. Okay, explanations not necessary. Convex mirror, the first use of convex mirror is rear view mirror in vehicles. You know what's a rear view mirror in a vehicle? The side mirror through which you can see the traffic coming from behind. Okay, this also you saw in that video how it is used as a rear view mirror. And one thing, if you carefully note it, the size of the image will be smaller, but it will cover a wide area. Okay, increases the field of view, means you will be able to get an idea about many vehicles coming from behind around a wider area. Then second use, they are used in street lights as reflectors. These are the uses of convex mirror. Now I think I left this part, difference between real image and virtual image. Let's try to understand. What is a real image? Real image is formed when rays after reflection actually meet. So all the images that are formed, we call it real. Why? Because this image is formed by the actual intersection of reflected rays. So here the reflected rays met. Even in the first three cases, we saw the reflected rays actually meet here. Okay, but in case of virtual image, this is the best example of virtual image. So convex mirror. Okay, so how was the diagram? So you had an object, so this will have its P and C this side, because if you complete the convex mirror, center will be somewhere this side. Okay, so this is F, this is P. So you take an object in front, first ray we're not taking an object, we are just taking parallel rays. Okay, let's not take a specific object, we'll just take parallel rays. Now because of this shape, in a convex mirror, the ray coming like this got reflected like this. Okay, that's because of the shape. Now because of the shape, I'm sorry, so this part should be shaded. Because of the shape, the rays will get reflected and they will go away from the mirror or diverging. We saw it. So one ray will go like this, another ray will go like this. Okay, so the reflected rays, if you extend it, they are going to go away from each other. They are not going to meet anywhere. Okay, so the distance between them only keep on increasing. But one thing is possible. If I extend it backward, means by putting a dotted line, if I extend these two rays, they will meet at one point, or we say they appear to meet at this point. That is where the image is formed. Now this kind of image is called virtual image. Here the reflected rays are not going to meet, but they appear to meet. You know the little meaning of virtual, no? Virtual is something which is not real, imaginary. Okay, what we are doing now, they are called virtual classes. We are not looking at each other, but we are, maybe you have to imagine that I'm standing in front of you and teaching and you study. So that's how. So virtual image is not a real one. It just appears to come from a point, or at that point image is formed. Even the image formed in a plane mirror, we use to look at our faces at home, they also form a virtual image. Okay, maybe when I stand in front of the mirror, I see another Susan inside, and I tell another person, see, there's one more Susan there, you can click a picture or something. It is not possible. You know that that is just appears to be. It is not actually one more person there. Okay, so that's how the definition of virtual image goes. Light rays from an object after reflection appear to meet. Okay, then second point, real image can be obtained on a screen. Virtual image cannot be obtained on a screen. Third one, real image is always inverted. Okay, real image, if you see in all the ray diagrams that we had, it was an inverted image. But virtual image, is an erect image. In front of a mirror, when you stand, your head is at the top and leg is at the bottom. That means it's an erect image that we see. So this difference between real and inverted image, real image and virtual image is very important. Now diagrams of virtual image, you don't have it in this class. We'll be doing it in 9th standard. So that's why I had to cut all the convex mirror diagrams. Okay, now about the homework for today. I assume that you drew these 4 cases along with me, these 2 cases along with me now in the beginning. Now what you're going to do is, one more time you're going to draw all the 5 diagrams. All the 5 diagrams continuously you're going to draw in your notebook. Okay, preferably without looking at the book. Okay, because now you're clear. You just have to remember a few things and keep drawing. There's nothing to memorize in this. You can't memorize the diagram. Okay, so follow the rules and you will get the image. And nature you have to write in the side. It will be a very good practice, because at least 2-3 diagrams will come from this, children. It's a very important thing. At least 5 marks question will come from this. So it's better if you practice again. So close your book and draw all the 5 cases without looking at the book. In case you have doubt, you open it, see it, and then close it. That will be a good practice for you. Okay. After that, turn to page 96. Exercise. You have done till question number 4. Now you are going to do 5, 6, and 7. Today you are going to write answers for 5, 6, and 7. And slight change. In 6th one, give any strike of 2 and write 3 uses of convex mirror. 3 uses of convex mirror. 7th one, state 2 uses of 3 uses of concave, and here instead of 1 you will write 2 uses of convex mirror. And as I told you, when you write the uses, you don't have to write the explanations. You just write till the point where I have marked. That much is enough. So as usual, you will finish it, click a photograph and send it by today, before today night. Thank you, children.